All right, in the next section, we are going to take a look at solving rational equations. So, in the last section, we just looked at simplifying rational expressions. Now, let's solve some equations involving rational expressions. So, let's start with a straightforward example. We just have one fraction equal to one fraction. Whenever we have a situation like this, another vocab idea that you've heard before is this is a proportion, right? To solve a proportion, we cross multiply. So what I'm going to do is multiply 4 times x plus 1 and 3 times x. Distribute the 4. We'll have 4x plus 4 equals 3x. Subtract the 4x over. Divide by -1. And we'll get that x is equal to -4. All right. So then we want to check this solution in our original equation. Whenever I am multiplying something by an expression that has a variable in it, there's always the possibility that we would get extraneous solutions. And that's true of any type of equation, not just rational equations. Whenever I'm multiplying by a variable, there's always the chance that we get extraneous solutions. So I want to take this -4 and plug it back in. So I'll have 4 over -4. And I'm checking to see if that equals 3 over -4 plus 1. So 4 over -4 is just -1. Here I get 3 over -4 plus 1 would be -3. So 3 over -3 is -1. This is a solution, okay? But we always have to check for an extraneous solution when we're solving rational equations, all right? Let's take a look at another one that's got one more step here. So on the left side of the equation, I am adding two fractions together, or two rational expressions together. Whenever that is the case, I want to go ahead and combine them and then cross multiply. So to add these two fractions together, that's what we worked on in the last section, I need to get common denominators first. So I'm going to multiply top and bottom here by x plus 1. So I'm going to have um, x plus 1 over x plus 1 times 1 over 6 plus, and then over here, I would multiply by 6 over 6, because remember, the goal is to get the same factors in each denominator. Okay, so now if I multiply these out, I guess I'll keep them equals 1 over x over there. 1 times x plus 1 would just be x plus 1, and that I can go ahead and multiply that out and make that 6x plus 6. Then plus 1 times 6 would just be 6 over 6x plus 6, and that's equal to 1 over x. So now I can combine like terms in the numerator, and I would just have x plus 7 over 6x plus 6 equals 1 over x. Now I'm going to cross multiply, okay, once I have one fraction equal to one fraction. So x times x plus 7 equals 1 times 6x plus 6. So distribute, we'll have x squared plus 7x equals 6x plus 6. And now I have a quadratic to solve. So to solve a quadratic, we first want to get everything on one side equal to 0. So I'll subtract the 6x over and subtract the 6 over. And we'll have x squared plus x minus 6 equals 0. Okay, and now we can solve this quadratic however we want. It's usually worth it to see if it factors, right? So I'm looking for two numbers that multiply to -6 that add to +1. And it looks like +3 and -2 would work. So this would factor into x plus 3 and x minus 2. Then setting each of those, forget my parentheses, setting each of those equal to 0, this will be x equals -3, and this will be x equals 2. So again, we do need to check these in our original problem. Okay, so let's start with -3. So if I plug -3 in, I've got 1 over 6 plus 1 over -3 plus 1 equals 1 over -3. So 1/6 plus 1 over -3 plus 1 would be -2. So that would be -1/2. And if I get common denominators here, this would be 3/6, right? So 1/6 minus 3/6 equals, and again, if I get common denominators, this would be -2/6, and that checks out. 1/6 minus 3/6 would be -2/6 equals -2/6. So -3 is a solution. Let's check 2. So 1/6 plus 1 over 2 plus 1 equals 1 over 2. So 1/6 plus 1/3 equals 1/2. Again, if we get common denominators, this would be 1/6 plus 2/6 equals 3/6, and that checks out. So neither of those are extraneous. My solution set is -3 and +2. All right. So let's just do one more example here. All right. Again, we've got two fractions on the left side of this equation. The first thing I want to do is get common denominators. So I'm going to multiply this first expression by x plus 2 over x plus 2. And I'll multiply the second expression by x minus 2 over x minus 2. So we will have something like this. So distribute the x, we'll get x squared plus 2x over, um, so if I multiply that out, I guess I'll go ahead and do that here. X plus 2 times x minus 2, so x squared minus 2x plus 2x, so those would cancel, and minus 4, then minus, we'll have 2x minus 4 up here over x squared minus 4 equals 4x over x squared minus 4. So then, combining like terms here, since I've got common denominators, I will have x squared, then 2x minus 2x cancels out, and then I will just have minus -4. So that would be plus 4 over x squared minus 4 equals 4x over x squared minus 4. Now be careful, even though these two things over here look very, very similar, I can't cancel anything out. And I can't cancel out terms that are being added or subtracted. Now, here is a slightly different situation that can save us some work. Now, since I have one fraction equal to one fraction, I could cross multiply and solve. But I have the exact same denominator on either side here. If that occurs, I can just take the numerators and set them equal to each other. Okay? Only if I have the exact same denominator on both sides, then I can set the numerators equal. So I would just have x squared plus 4 equals 4x. Then we've got another quadratic to solve. Subtract the 4x over. We'll have x squared minus 4x plus 4 equals 0. And certainly try to factor. So two numbers that multiply to +4 that add to -4. I think -2 and -2 would do that. So we'll have x minus 2 times x minus 2. So the only solution, since these are the same, would be x equals 2. All right, and again, we need to take that and plug that into my original problem to see if it works. All right, well, the first expression, I'll have x over 2. Oops, I guess I should be plugging 2 in there, right? I'm plugging 2 in everywhere I see an x. So I will have 2 over 2 minus 2. Right? I'm replacing both of these x's with a 2. So just that first expression, I end up with 2 over 0. I can already see that I'm going to have something that's undefined. I don't even need to write out the rest of this expression. Right? I mean, I can. 2 over 2 plus 2 equals 4 times 2 over 2 squared minus 4. And I can see that I'm going to get 0 here and actually 0 here. But all I need is a 0 in one denominator for this to not work. Right? If I plug that back in and I get something that's undefined, that is an extraneous solution. So since that was my only answer, that means that this problem has no solutions. Okay, so it is important to plug those answers back in. All right, so that is it for this video. The final question is going to pop up asking you what questions you have.